Hello guys! Welcome to our second set of notes this week. The good news is this is your second to last set of notes for the entire 2016 year. Yay! Anyways, let's go ahead and get started. We're going to be talking about the periodic table today, so that is your title. The essential question is, how does the periodic table organize all of the elements in the universe? As you know, title goes up at the top, essential question below that, and then you divide the rest of the page into your two columns. Small column for key points, questions, important words, etc. And the bigger column is for your notes. At the very end, you should be writing a summary. Make sure you're getting all the information down because at some point you will have a quiz on your notes, and you want to be able to get a 100% on that. So, let's get started. Periodic table of elements. It is basically a fancy chart that organizes all of the elements, and it organizes them by patterns in their properties. The first periodic table was developed by a Russian chemist, if I can talk properly, by the name of Dmitry Mendeleev, and this was back in 1869. At the time, there was only 63 elements that were known, and he organized them by their atomic mass. As he organized them, he was actually able to predict the discovery of unknown elements by gaps in the periodic table. So as he was laying out the elements they knew of, there were little gaps that were there if he followed the pattern he was using. So he was able to predict that, hey, there's an empty spot here, so there must be an element somewhere out there that fits in this spot. Which is kind of cool. He also discovered something called periodic law. And basically what that is when you organize elements in order of increasing atomic mass, there's a repeating pattern of different chemical and physical properties of the elements. So basically the periodic table, it follows different patterns. Now, our modern periodic table has a lot more elements than Mendeleev's did, and it is organized by atomic mass and properties. We also organize the elements in groups and periods. Groups are the columns going up and down, and we also call them families. Each group or family has characteristics and properties that are the same. Periods are rows going across, and it's the same thing. Each row has characteristics that are similar for all of the elements in that particular row. As you go down the groups and across the periods, the atomic mass increases. Also, as you look at the periodic table, on your left are metals and on your right are nonmetals. So the pattern is that it becomes less metallic the further you go to the right. Let's talk a little bit about metals and nonmetals. Properties of metals, they are shiny, they are malleable, which means they can be flattened. They are ductile, which means they can be pulled. Metals are also good conductors of heat and electricity, and some of them are magnetic. Most are solid at room temperature. The only exception is mercury. In general, density, melting point, hardness, those things will increase when you go from the left of the table to the right, generally speaking. And reactivity, as you're going from left to right, actually decreases. So as you go further to the right side of the table, those elements are less reactive than the ones on the left. Nonmetals are not metals, as the name implies. They are dull, they are brittle, so they're not shiny, they're not malleable, they're not ductile. They're opposite of metals. They are poor conductors of heat and electricity. They have lower densities, lower melting points than metals, and most of them are gases at room temperature. Some of them are liquids, there are a few that are solids, but for the most part at room temperature they are gases. And there's actually not a whole lot of nonmetals, and you can see in the picture off to the side, those are actually all of the nonmetals. That's all of the nonmetal elements. There are not a lot of them. We also have something called metalloids. These are elements that have some metallic characteristics, but they're not actually metals. They are hard and brittle. Some of them can conduct electricity under some conditions, but not all conditions. And for this reason, we call them semiconductors, which isn't necessarily a word you need to know for vocabulary, but just so you know. Also, they are solids at room temperature. And there's not a lot of elements we consider metalloids. When you look at the periodic table below, all of those green elements, those are metalloids. So not a whole lot of them. Another thing we're going to talk about is something called valence electrons. This is another property that elements are organized by. When it comes to electrons, they are circling around the nucleus. All right. Now, they're found in what we call different energy levels, different shells, different orbitals. Think of it kind of like the solar system. At the center of our solar system, we have the sun, and then you have all of the planets orbiting around the sun. So we've got 8 planets plus a handful of dwarf planets and a whole bunch of other stuff. So you've got all of these things orbiting around, and each of those things has its own orbit. So think of it kind of, think of an atom kind of like that. You have the nucleus in the center, which would be kind of like the sun. And then you have different levels, different orbits of electrons. The more electrons there are, the more energy levels or orbitals there are. So as you go down the groups in the periodic table, the number of levels will increase. And you'll see those levels referred to by different words. The picture off to the side refers to them as rings. You'll sometimes see them called shells, orbitals, energy levels, and I kind of jump back and forth between the different terms. So just so you know, there are different words for that. Now, valence electrons are the electrons that are in the outermost shell or orbital. And that's in the highest energy level. So the further out they are from the nucleus, the more energy they have. Now, the valence electrons are in the outermost level, and they are the ones that are involved with chemical bonding. When it comes to electrons being in different levels, it's very complicated. It's not easy to explain, but long story short, valence electrons are the outermost level, and atoms can have up to 8 of them. The only 2 exceptions to that are hydrogen and helium, because they have hydrogen only has 1 electron and helium only has 2. So those 2 are such small atoms they can't have more than 2 valence electrons. As you go across the table from left to right, the number of valence electrons increases. And we skip over the transition metals in this when we're looking at this, because they follow their own rules. They're a group all their own. So if you look at the smaller picture at the bottom of the screen, hydrogen and helium are pointed out, and going from the left to the right, that first row has hydrogen at the top of it. That whole, not row, column, that whole column has one valence electron. The next one over, that's the second column, has two valence electrons. And then we have our transition metals on the inside. That's those columns that are shorter than the others. Like I said, they follow their own rules. They're a hot mess that we're not even going to deal with. We'll just leave it at that. So the next column right after the transition metals, that's our third tall column, and that column has 3 valence electrons. The next one is the fourth tall column. It has 4 valence electrons, and so on all the way across to that last column, which has 8. But we'll talk more about valence electrons another time. So moving along. Summary. You know what to do. 3 to 5 sentences sum up what we talked about. We talked about a bunch. So you got a bit of writing to do. And that is it.